x also is e to the x. And the other derivative rule that we came up with is if f of x is equal to the natural log of x, then the derivative of f is 1 over x. So these were our two new derivative rules, and we talked about how to come up with these rules, and we derived both rules. But at this point, for today, we just want to make sure that we know these, just like we know that the derivative of sine is cosine, the derivative of cosine of x is negative sine x. Okay, so I'd like to talk about a few problems out of the text, and I'm going to pick a few even problems, and then I'll open up the floor if anybody has any specifics on the practice problems that were assigned. But out of section 3.3, let's first take a look at number 4. When we talked about these derivatives, we didn't really get a chance to do any examples where we looked at the derivative of natural log of x, and so I want to get a couple of those examples under our belt. All right, so number 4 is f of x is equal to the cosine of the natural log of x. Our goal is to find a derivative. Now, when I look at this function, at first glance, I see a cosine, and I see cosine of something. Okay, and so these are nested functions, which means I want to use the chain rule. And so when I see this, I immediately think chain rule because I have nested functions. Now, you may have looked at that and said to yourself, oh look, there's two functions that are multiplied together, and so I'm going to be using the product rule. And here's why the product rule will not work on this. Okay. And so I'll write this in a different color. If I wrote down cosine of natural log of x and said, oh, I'm going to use the product rule, well, then I might be thinking that my first function is cosine and my second function is natural log of x. And so the second function is fine because natural log of x is a function, and that's perfectly legitimate. But my first function would be just plain COS. And COS by itself is absolutely meaningless, okay? Because this is really an incomplete sentence. This is cosine of what? And so I don't know what I'm taking the cosine of. And so this is not a legitimate choice as a function because cosine cannot live by itself. It has to be cosine of something. So I definitely do not want to use the product rule. All right, same is true. Other functions that cannot live, other functions like cosine. So cosine with nothing on the end dies. The same with sine, tangent. Any of these functions need something after them to have them make sense. Same with natural log. Natural log must have something behind it in order for the function to make sense. I think that's all of them right now. So those are the main ones. Okay, so back to our chain rule. So I've got f of x is equal to cosine of natural log of x. Our inside function is natural log of x, and our outside function is cosine of x. So my chain rule says take the derivative of the outside, keeping the inside the same. So derivative of the outside will be negative sine of keeping the inside the same, so negative sine of the natural log of x. Derivative of the outside, keeping the inside the same, times the derivative of the inside. The derivative of natural log of x is 1 over x. And so this is my derivative. Okay, are there any questions about that?
So is that just something we have to memorize?
This one right here?
Yeah.
Yes, that's going to be something to memorize. But we kind of talked about where it came from and we derived it, but it's one you want to memorize. Kind of like you memorized the power rule. Okay, other questions or comments about this rule? All right, so let's compare this to number 6, which is slightly different. In number 6, we have f of x is equal to the natural log of the fifth root of x. Now, when I look at this function, I'm not really happy because there's not a lot of parentheses going on. So just like this last one, my first thought might be to try and use the product rule and say square root of, or fifth root of x times natural log, but natural log sitting by itself doesn't really even make sense. Okay? So the first thing I might do here is to rewrite this function as f of x is equal to the natural log of x to the 1/5. And that x to the 1/5 is really inside the parentheses because we're taking the natural log of the x to the 1/5. Okay, so I've now rewritten the function, and now when I look at this, I see a chain rule happening, natural log of something fancy. And so our inside function is x to the 1/5, and our outside function is natural log of x. So unlike the last one, in this last example, natural log showed up on as the inside function. On this example, natural log is the outside function. Okay, so let's take our derivative. Chain rule says take the derivative of the outside, keeping the inside the same. Now, the derivative of natural log of x is 1 over x. So what we're going to do is we're going to write derivative of the outside is 1 over whatever was in the inside. So 1 over x to the 1/5 times the derivative of that inside. So the derivative of x to the 1/5 is 1/5 x to the negative 4/5. And here is our derivative. Any questions about that one? So in general, if you have y is equal to natural log of squiggly blob, then when you take your derivative, your y prime, derivative of the outside keeping the inside the same, well, that's going to be 1 over squiggly blob times the derivative of that squiggly blob. All right, so that's our chain rule for natural log. But it still follows derivative of the outside keeping the inside the same times the derivative of the inside. Okay, any questions or comments about any of those?
What were the practice problems that we were supposed to do? For some reason I didn't.
So the 3.3 practice problems were numbers 3 to 13 odd, 17 to 23 odd, and 39, 41, and 55. Okay. All right, so let's look at one final example here, and maybe I'll hold off on answering questions about these particular practice problems till next class, so everyone has a chance to think about them a little bit more. Let's take a look at number 22. Number 22 is y is equal to e to the negative 5x times cosine of 3x. Now the textbook writes it exactly like this, but whenever I see cosine of something, if it's fancier, I'm going to put parentheses around that 3x just to clarify for myself that it's cosine of 3x rather than cosine of x, and then times 3 or something like that. Okay, so we've got y is equal to e to the negative 5x times cosine of 3x. So take a look at this function. And I'd like you to think to yourself, what is the first derivative rule you want to think about? So think about it for yourself. Now turn to your neighbor and tell your neighbor what rule we're going to be applying first on this function. All right, did anybody agree with your neighbor? Manny, what did you guys decide?
Product rule first.
product rule first. Okay, so this seems really sensible because what we've got here is two separate functions that are multiplied together. There's nothing that is surrounding everything else. There's no sort of nesting going on that involves nesting of entire functions here. And so product rule is going to be a really good choice. Now, I do see some things such as a 3x inside parentheses that say, oh, eventually I'm going to have to use a chain rule, but that nesting only occurs in the second half of the function. It's not nesting that involves the entire function, so chain rule may show its face, but not right away. First is the product rule. So we've got y prime is equal to first e to the negative 5x times the derivative of the second. And since our functions themselves, the first and the second, are somewhat more complicated, I'm going to write out this product rule. So first times derivative of the second plus second cosine of 3x times the derivative of the first, derivative of e to the negative 5x. Okay, so here is our product rule. We now need to analyze each of these two derivatives that we've written down. So our first one here is derivative of cosine of 3x. And because that 3x is fancier than just an x, we're going to have to use a chain rule here. So I'll copy down e to the minus 5x. And the derivative of cosine of 3x, well, derivative of the outside is negative sign, keeping the inside the same, 3x. Derivative of the outside, keeping the inside the same, times the derivative of the inside, so times 3. So first times derivative of the second plus second cosine of 3x times derivative of the first. So now we want to analyze taking the derivative of e to the negative 5x. And what's going on here is that we have something fancier up in the power. And so again, we've got our chain rule, where our inside function is negative 5x, and our outside function is e to the x. So derivative of the outside, keeping the inside the same, that's e to the negative 5x, times the derivative of the inside. So the derivative of negative 5x is negative 5. This is our final answer. All right, are there any questions about that one? Going once? Going twice? All right, so Jeff?
So just because the derivative of e to the x is e to the x, it doesn't, you still have to derive the 5x over e.
That's right, so it's real similar to this one up here. If I just have plain e to the x, then our derivative is e to the x. But if I have e to the something fancier,
Right.
then we have to apply the chain rule, which says derivative of the outside keeping the inside the same times the derivative of that fancier stuff. Yep. All right, other questions or comments about number 22? Okay. So, what's that?
Thanks for doing that.
Okay.